Hello everyone, this is GATE 2022 Life Sciences, Section P Biochemistry, question number 32. A dye was allowed to undergo migration on a chromatographic paper using a solvent. The dye and the solvent front migrated 5 and 20 centimeter. Okay, so we'll discuss this, what is this solvent front and what is dye respectively. From the point of origin, the retention factor rounded off to two places of decimals for the dye is dash. This is the NPTEL online course reference for this question. So how to calculate retention factor? So retention factor is calculated for the techniques like thin layer chromatography or paper chromatography. Okay, thin layer chromatography or paper chromatography. We all know that in thin layer we use a thin layer of a silica which is a kind of thin layer of silica on which the solvent is run, and we put the sample. And on paper chromatography also, the paper through capillary action, the solvent will run up front. Okay, so here they have given this spotting line. This spotting line is nothing but point of origin. Okay, this is known as point of origin. So what is this spotting line? So in thin layer chromatography or paper chromatography, we have a chamber, we have a solvent chamber, okay, in which we have a solvent of our interest, okay, and when we put a paper inside or a thin layer silica plate inside, what will happen? This paper will be dipped in the solvent, and through capillary action the solvent will run up front, right? So the point at which it is submerged is known as point of origin, right? And the sampling is done somewhere just above the point of origin. The sampling is done either on the point of origin or just above. So why it is significance? Why it has this significance? Because if we put our samples here, somewhere here, and when we dip our thin layer of silica or the paper chromatogram here, our samples will get dissolved in this solvent. Okay, solvent is chosen such a way that the dye or the solute which we have used has a solubility in that solvent. So we have to make sure that the sample which we are loading are just above the spotting line or the point of origin. Okay, so through capillary action, the solvent will travel up front, and it will travel a particular distance known as and it will reach a solvent front. Okay, and that distance is B. So the solvent front distance from point of origin is B, right? This distance is B. Okay, then we'll spot our sample. In this case, we are spotting a dye. Okay, this dye could be any dye. It could be, for example, we use this to separate different chlorophylls, chlorophyll A, B, right, different plant pigments. So we are spotting that sample here, and we put this paper or a thin layer chromatogram in the saturated chamber. This chamber is saturated with this solvent, right? And after putting the dye, this sample or a dye will travel along with the solvent front, right? It will travel along with the solvent front, and it will travel a distance known as A. So the retention factor formula is distance traveled by solute A upon distance traveled by a solvent P. Okay, so very simple. So retention factor RF is distance traveled by solute A or dye in our case upon distance traveled by solvent. We already know from the question A is 5 centimeter and B is 20 centimeter, right? Very simple. So you just have to plug in the values. So this is equal to 0.25. Okay, very simple problem. So the correct answer is 0.25. Thank you.